Okay, so in this example, there's a golf company. They want to show that your golf game improves with their new clubs. So this is an example of a dependent sample because the numbers come from like the same type of population, like the same type of person that's running them. It's the same person running the old club and new club, so they're naturally paired with one another. Okay, so we can calculate the difference for each of these columns. Just make sure you watch out. It's not this one subtracted by this one. Okay, they say new clubs has to come first, then subtracted by the old clubs. So you do 73 minus 74 for your difference here, which would make 1, right? 70 minus 69, that makes 1. 71 minus 73, that makes -2. You could keep going that way, but it's actually going to be way quicker if you pull up your data in Newton and highlight it all, and then open up a Google Sheets document where you can copy and paste it. Okay, because if you do that, if you got it copied, right-click it and copy, come over here, right-click paste, then you don't have to type in all the numbers again, and now you can actually tell Google Sheets to quickly calculate the difference. Type in equals, and then remember it's supposed to be new clubs first according to their formula. So I typed in B1 subtracted by, you can click I guess, A1, that works too. And if you do it by a formula, by telling it what cell to do, then you can click and drag and it repeats that for all the other cells. And so now you can calculate that mean for the differences that we need. Equals average, click and drag, and then we can calculate the standard deviation too. We type in equals stdev.s, open parentheses, click and drag, close the parentheses, and now we have everything for the formula that we need for our test statistic. Okay, so this is our test statistic. We've got the mean. This is almost always 0, okay, because we're usually testing that the difference between the two is 0. Like they wanted to show, their alternative hypothesis was that the difference was less than 0. It was that the new club is, let's see, new club subtracted by old club. Well, actually, I'd have to think about that for a second, whether that should be less than or greater than, but the point is you're going to plug in 0 here, okay? Let me get that data set. So for the mean, we're going to plug in -2. For the population mean, we're going to plug in 0. Standard deviation, we got 2.2678, and that's being divided by the square root of 8. Okay, so do this out on paper. Write out the square root of 8 in one step. -2 minus 0 just makes -2 up top. And we're dividing that by the square root of 8. So there's our square root of 8, 2.8284. And now when you divide these two numbers, you get this big number, 0.8018 for our denominator. And then when you divide those two things, you finally get your test statistic. I'll just remember it's negative. So 2.49 roughly. Negative 2.49 for our test statistic.